Hi to everyone. Welcome to IG Bits. We train, you learn. The learning appetite is always keep us motivated to learn more things, isn't it? So I hope you have enough energy levels to run through today's class, is it? So today we shall start motions in a plane. Uh, I have seen that many of you asking to revise a concept of vectors at a quick note. So probably we will take it up the topic today, and then we shall go through all the concepts at the whatever max that is possible to cover today. So without further delay, let's get started. Folks, one thing I wanted to let you know that our YouTube channel is ready, and then you can feel free to visit youtube.com at igbits. We have started uploading all the previous videos. The few of them already made available, and then few are in process of uploading. Sooner we think we are going to complete, and then you will have like a full access. One request from my side: you can extend your support to help your friends who are in need to learn, you know, at their own time. So requesting you to subscribe the channel and also help your friends, asking them to subscribe our channel, because we need the support. Thanks for all your support, and then making this happening. Thanks again. Thanks a lot. In last class, we studied the concept of position, displacement, speed, velocity, acceleration, right? Those are needed to describe the motion of object along the straight line. So we found that the direction aspect of those quantities can be taken as a positive or negative, isn't it, right? As in one dimension, only two directions are possible. But in order to describe the motion of object in the two-dimensional, like a 2D, like a plane, or three-dimensional space, we have to use vectors, and hence it is essential for us to recap of what is the concept of vectors and how you gonna apply them for solving the problems, is it? So let's get started with basic note. We know that the physical quantities, right? So how do you classify the physical quantity with respect of the vector concept? We have two quantities, two types of quantities. So a scalar quantity and then vector quantity. So you remember what is meant by scalar quantity? If we studied like a mass, length, time, fundamental quantities, right? Those are the scalar quantities. Temperature, work, energy, and then many more. If you can complete your physics, then you should be knowing that what are all physical quantities which are classified as a scalar versus like what are all the physical quantities which are classified as a vector. When I say physical quantity, it is a combination of both fundamental quantities and derived quantities. Make note of it. So now the question is, how do you distinguish a scalar quantity and versus like a vector quantity? So vector quantity, basically we talk about like a displacement, velocity, acceleration, force, extra. So any quantity when you measure, right, what we are talking about is like we have some magnitude, correct? That is what I think we studied in the previous class. Magnitude and units, that's all we studied, but we are extending little more that part. So not only the magnitude, we are also giving little weight to the direction. So if you look at a scalar quantity, the scalar quantity is only having the magnitude but no direction, right? That is called a scalar quantity. Whereas in a vector quantity, we have both magnitude and direction, right? So for now, I think you remember the people who already know. I think for sure, I think they understand what I'm talking. The people are just about to familiarizing this concept. Probably for them, my request is just remember the definitions and then see like how you gonna actually helping to solve your problems. So you sure, I think when you started solving the problem, you will be able to you know uh, aggregate the concept versus like apply the concept into solving the problems. So for now, in a nutshell, scalar quantity has a magnitude and vector quantity both magnitude and direction. And then one more important parameter that you have to understand is like how do you add two scalar quantities or two vector quantities like that. So the rules for combining a scalar are rules of ordinary algebra. We know, right? Ordinary algebra, addition, subtraction, multiplication, division, as if like adding two numbers or multiplying two numbers, subtracting one number from another, things like that, right? So these are the ordinary algebra. All these scalar quantity for which you can use the ordinary algebra. That is a small tip for us. Whereas in vector quantity, you should not use the ordinary algebra. You should use the vector additions. Vector laws of addition is what we have to use. We will see the few concepts of how vector addition and subtraction can be done. All right. So recapping again, classification of physical quantity. The physical quantities are all measurable quantities. Make a note of it. We have scalar quantity and vector quantity, and then scalar quantity further defining into magnitude and the rules of ordinary algebra, which is follows. So whereas vector quantity we have a magnitude and the direction. We also talks about like the vector law of addition is what we use for adding two vectors. Okay, so let's move on to the next topic. Let's find out total current from this below diagram. If you look at this diagram, what you are understanding, there are the two currents which are actually joining at a junction, and then combining current would be leaving from the junction in third current element. So sounds like this is a current law in electricity. Algebraic sum of currents entering into junction is equal to algebraic sum of the currents leaving from the junction. So if you look at that as a concept, what we have see here is, let me open my pen. So the I would be combination of input, sum of the inputs, which is 5 amperes plus 6 amperes is 11 amperes would be our answer, right? If you look at this, is simple method, right? Ordinary algebra is what we use. Well, let's look at a few more. Addition of two vectors. Who is going to answer this question? So when we say vector, what we spoke about, we have a magnitude and direction, right? While doing like an algebraic addition, we need to understand like a direction also. The value should be a summing and direction should be noted, isn't it? So let's always assume that arrowhead towards to right side would be a positive value, towards to negative would be treated as a negative value, right? I mean left side is a negative value. In our cases like this first example, we have two vectors which are towards the right direction, so same direction to the right direction, right is a positive. So how do you calculate now? Net value 10 plus 8 equal to 18, right? Are you clear? We are talking about this is a vector notation, but we are talking about a positive or negative. This is a positive value, this is also positive value, that is our say, right? This is also positive, so right direction. Let's look at the second example. So this vector having a magnitude 10 but the left direction, so it's nothing but it's a minus value. This one towards the right positive side, right? Positive value is a 8 magnitude, so the total would be minus 10 plus 8 equal to minus 2. So net would be 2, magnitude of vector is 2 towards to left side. Okay, think about the next one. I have a vector 5 towards the left plus another 5 towards the left. What would be net? So it's a left direction, so minus 5 plus minus 5, isn't it? So total would be minus 10. That means like net vector would be 10 newtons towards the left side. Are you clear? Let's look at next example. So we have a for the simple problems. The ask is like find out a net force on each. Let's look at this one. So we have the body and then we are applying two forces, 10 newtons of each. We are applying an opposite direction on the body. So what would be the net force on the body? That's what the question, right? So since both are actually opposite direction, the direction, right? If you say like one is a positive direction, other would be the negative direction. So towards the right would be a positive, and then towards the left would be negative. Let's assume the case like that. So 10 and 10 and opposite direction is what we are talking about, right? So if you can market this, what we are saying is like this is a positive 10, this is a negative 10, right? So net would be 0. So net force applied on the body would be the 0 because applied force are in equal magnitude but opposite direction. This is how you see the resultant would be 0 newtons. Let's look at this one. So here 10 volts applying an opposite direction to extract the body, but what would be the impact? One is a positive direction, one is a negative direction. Net would be 10 minus 10, again 0 newtons. So no impact on body because the net force applied on the body would be 0 because you are balancing the applied forces. Okay, so look at this one now. So left side, towards the left side we are actually applying at 10 newtons, and then towards the right side you are applying 5 newtons. This is a positive, this is a negative. So what would be the net? 5 minus 10 newtons equal to minus 5. That means so the net force applied on the body towards to the left side, right? I mean towards the left side. So 5 newtons. That's the net force. You see, the simple algebraic math is what we are using here. Look at other way. So we are applying 5 newtons towards the right and then 10 newtons towards the right. So probably this is a push and this is a pull, right? So the total force, net total force applied in the body would be sum of these two because we on the same direction. So 5 newton plus 10 newton equal to net 15 newton force is what we are applying on the body. So ultimately body should move towards to the right direction, in this case left direction. In the above two cases is stationary. We are not actually making any difference for the body movement. So this is the best example to understand like how the forces, the magnitude and direction helping you to actually calculate the net value. All right. Representation of vectors. Since we know now the definition of vector is nothing but it has both magnitude and direction, right? This is how you are representing the vector. F on top there is an arrow, right? So let's say like we have a vector of length, right? For instance 10 newtons of force is what we are representing in this line. What we see is like 10 newton is like a magnitude, and then we also indicated the direction, right? This is what it is. But how do you represent a magnitude? This is how I think we represent the modulus of f is what we representing for magnitude of vector. So length of the vector is nothing but magnitude of vector, and hence we are representing. So v prime of vector, and then arrowhead indicates direction of the vector. Now it is towards the right. Any question? Yeah, very simple thing. This is the vector representation, this is the magnitude, this is the direction, and then when you wanted to represent a magnitude of given vector, the modulus of f is what we have to show for the magnitude vector. The direction is always, we know, this is arrowhead. Let's look at a concept of equal vectors or parallel vectors. So what is the definition of equal vector? Let's say if you have a two or more vectors having a same magnitude, same direction, irrespective of their position in the space, called as a equal vector. So we are not worrying about where that position starts, but as long as the two vectors having the same magnitude, because length of the vectors should be the same, and then same direction, then we can call those two vectors as a equal vectors or parallel vectors. Let's see the example. Okay, so I have F1 and F2 two forces, and the length of the vector is 10 Newton, 10 Newton. Both are at both directions shows me like towards the right. Is it? So the both magnitude direction of for the two vectors seems same, and hence I can call these two vectors are equal vectors. So both magnitude and directions are same, and then they are said to be equal vectors. Alright, let's look at this example. I have F1 and F2, and then length of the F1 vector and F2 vector each 10 Newton. Until this point is fine. Magnitudes are same for both vectors. What is the difference is there is a little deviation in the direction. You see, and hence because of the property, by definition, what you're saying, like if we are talking about in order to you to call equal vectors, you should have to see both magnitude and direction remain same for both. So in this case magnitude is same but direction is variant, so and hence this is called unequal vectors. Look at this example. I have two vectors and then I have a different magnitude in different direction. Obviously this is not an equal vector, so unequal vector. So we have to distinguish both equal vector and unequal vector. Look at this case, direction is same, but the magnitude is different. The 5 Newton and 10 Newtons, two different lengths of the vectors, but the directions remain same. But in this case also, we can call these are unequal vectors. So do you get it? Equal versus unequal vectors. Very good. Let's look at opposite vectors. What is meant by opposite vectors? I think you get a clue that probably the direction of given vectors are in opposite direction. Is it? Any two vectors of same type which are equal in magnitude but opposite in direction is called a opposite vectors. We also know them as negative vectors or parallel vectors. Okay, let's look at this example. See, I have two vectors and then F1 and F2, both having same magnitude 10 Newton, 10 Newton. What is the difference? Direction. Both are opposite directions. So magnitude is same but direction is opposite to each other, and hence these two vectors are called as opposite vectors. You can look at this also, right? So I have two forces of equal magnitude and direction is opposite. Do you see? And we can also treat them as an opposite vectors. Are you clear? The difference between the equal vectors and the opposite vectors? Very good. Another important concept is null vector, zero vector. This plays a very important role while solving vector algebra problems. A vector having a zero magnitude, right, is known as a null vector or zero vector. So the direction is undefined. So dot, for example, is a zero vector. So magnitude is zero, but direction is unknown. Right? This is how you have to understand the concept of null vector. Clear? Let's move on to next topic. Let's look at a unit vector. We have a vector, length of the vector, and then there is a direction shown in the picture, right? This is a vector. So what we are saying here is the unit vector is nothing but the ratio of given vector divided by magnitude of vector. Given vector divided by magnitude of vector. So magnitude of vector is what we have shown here. The modulus of A is what? The representation of magnitude of vector. So unit vector is a vector that has a magnitude of 1. So when you calculate unit vector, the value would becomes 1. The magnitude of unit vector is 1. We also call unit vector as a directional vector. We know that, right, any physical quantity which has both magnitude and direction is stated to be a vector quantity in vector algebra, right? When you say unit vector, what we see is a magnitude multiplied by direction. Magnitude for unit vector is 1, so all you have to see is a direction. The representation of vector is equal to magnitude into direction, right, in a way. So modulus of A is a magnitude, A cap is a direction. A cap is nothing but vector divided by magnitude. So obviously it becomes like A only, the vector quantity. So we have to use this formula in most of our, vector algebra problems. Properties of vector. So we have a commutative property of addition, A plus B equal to B plus A. Associative properties of addition, A plus B plus C equal to A plus B plus C. Distributive properties of addition, scalar quantity K multiplied by A plus C is equal to Ka, K times A plus K times B. Adding zero vector is null vector, right? So there is no change in vector. A plus O, A plus 0 equal A. Associative law of vector, let's say like the product of scalar quantities, right? M into n times A equal to mn times A. So this is how we can simplify our vector algebra problems. The properties apply to vector addition and scalar multiplication. Clear? Vector addition, scalar multiplication. Let's look at this example. I and j. When you look at it two, elements of vector, we can think of probably this is like a two-dimensional vector. If you look at a plane x and y, right? This is x direction, this is y direction. We have a 2 units in I cap, 3 units j cap. This is how you can see ij 2 plus 3j. How do you represent? An x direction 2 units, 2i, and y direction positive x, right? Y positive y 3j. This is how you represent vector 2i plus 3j. Are you clear? So you see that, right, in your coordinate geometry, this is a positive x, this is a negative x, this is a positive y, this is a negative y. This is how I think you are using this representation. Try out this one, minus 4i plus 4j, minus 4i plus 6j, minus 4i, right? 4i would be the left side. So I see this is a 4i towards the left. 6j is a positive. So j towards the positive, 6j. This is how you represent. Alright. What about the next one? 5i. So 5i positive direction. 7j negative side. So downward. So minus 7j. I mean this is again negative. This is how we can represent. Right? This is a positive. This is a negative. This is a negative. Right? This is a positive. First quadrant, second, third, and fourth. Clear? Well done. So similarly, you can also think of like 3-dimension. So what happened? 3i plus 2i plus 3j plus 4k. Then it is a 3D representation of vector in 3D is called space. Right? This is simple one, simple concept. So one more important concept, magnitude of vectors. Let's look at a plane. Plane means like xy plane, yz, right, xz. These are the three planes that we can talk about. Currently if you look at this diagram, what we have seen is like the vector which is on xy plane, right? So this is a 2D plane. So now how do you calculate the magnitude of this vector? We have a ax in the direction of x, ay in the direction of y, right? Axi plus ayj, I component, j component is given, right? These two are the vectors. So if you look at this one, right, ay, which is nothing but here only ay, no, both are parallel vectors. So this is right angle triangle. So two sides are given, and then you have to calculate the hypotenuse. This is the your resultant vector. How do you calculate? According to Pythagoras, the hypotenuse will be getting by square root of ax square plus ay square, side square plus side square, is it? This is what your resultant vector, in our case a. So you have to remember, so magnitude of a will be getting square root of I component square plus j component square, x square plus y square is nothing but your magnitude. Clear? So we will be using like, you know, the problems. Let's say I have 3 2i plus 3j. This is in vector a. So someone asking you to calculate the magnitude of vector. How do you calculate? So square root of 2 square plus 3 square. How much? 4 plus 9. So root 13. Clear? So you can extend same principle for even 3-dimensional. Let's look at a position vector. So I have a, you know, the plane, xy plane. I have two vectors. In a way I say like the point P and point Q. The position vector R, how do you represent it? R is defined as a fixed vector which locates a point in a space relative to another point, right? This is a PQ. Let's say the position vector R PQ, P to Q. If I say that, then how do you represent? RQ minus RP would be your position vector. What is an RQ? A to B to 0 minus A1 B1 0. How do you represent this one? A2 minus A1 I plus B2 minus B1 J plus 0 K, because 0 0. This is how you have to see. So if you represent it, how do you represent this one? A1 I cap plus B1 J cap plus 0 K. This is nothing but your RP. So whereas RQ, A2 I, this one I, right? Okay. Plus B2 J plus 0 K. This is how to look at. Okay. So the answer would be PRQ is a position vector which is nothing but A2 minus A1 into I, B2 minus B1 to J and 0 K. Clear? If you have a space, then you will have a K component. Then you have like a, let's say C2 minus C1 of K. Isn't it? This is another way of representing. You're clear, I believe, right? Let me know if you have any question, guys. So we have seen magnitude of vector in 2D. Now you can see 3D. xyz plane, axi plus ayj plus azk. The simple theory, right? In if at all a equal to axi plus ayj, then what would be the magnitude for this 2D? So magnitude of A would be ax square plus ay square. Correct, no? Similarly, if you have a 3D, the answer would be magnitude of A would be root of ax square plus ay square plus az square. This is what the value of the magnitude. Clear? Very good. How to resolve vectors? Resolving vector is nothing but like an identifying of horizontal component and vertical component of that vector. As simple as, right? If you look at a two-dimensional, we have a x plane, xy plane, right? So this is I direction, this is j direction. What you are saying is that your resultant would be f. That's what is given. Let's say the resultant vector making an angle with x direction is theta, right? This is a right angle triangle in a way. So if you can calculate cos theta is nothing but how much? Let's assume this is O, A and B, right? AB is an opposite direction, OA is a adjacent direction, OB is hypotenuse, side hypotenuse as per Pythagoras law, is it? So cos theta would be OA by OB, is it? OA means OA remains, that is a horizontal component, divided OB is a F. So OA equal to F cos theta. Agree? So this means horizontal component is F cos theta, horizontal component. So let's look at a sin theta. Sin theta equal to what? Opposite AB, opposite side AB by hypotenuse OB. Right? So AB remains same for a minute. This is our vertical component. OB means hypotenuse. So AB equal to F sin theta. Agree? So how do you represent now? With combination of horizontal component and vertical component, the vector representing in I plus j notation. So F cos theta in I direction plus F sin theta in y direction. This is how you represent a vector. Let's move on to next topic. Next problem, find out a horizontal component. So who is going to try? It's a simple one, right? You can now try out and give me an answer. The clue is theta is 37 degrees. You know the triangle with the angle 37 degrees. You got to remember this one, right? This should be 3, 4, 5. This is a triangle, 3, 4, 5 right angle triangle. So you know what is meant by cos theta here. Cos theta would be 4 by 5. Sin theta would be 3 by 5. Okay. So the horizontal component is only f cos theta, right? So f is given. So I missed out, but there's a 10 newtons. Now you look at, so f cos theta would be your horizontal component. So f is 10, cos theta is 4 by 5. So 5 ones are 5 twos are 2 4 8. 2 times 4 is 8 units. So 8 newtons is horizontal component. What would be the vertical component? If you look at, this is nothing but f sin theta, isn't it? F sin theta. So 10 in multiplied by 3 by 5. So it's nothing but 2 times 3 would be 6 newtons. So how do you represent this one now? F equal to 8 in horizontal direction, I plus 6 in vertical direction, J. This is what this. So magnitude of F is, how do you calculate? 8 square plus 6 square, is it? That means like root of 100, so 10 newtons. Clear now? So you can extract two ways. You can, from the given vector, you can calculate a magnitude. From given magnitude and angle, you can also calculate horizontal component and vertical component. Let's see the next one. The vertical component of vector is equal to horizontal component. What is the angle made by the vector with x-axis? That's a theta, right? What the given is, two components are equal, so f sine theta equal to f cos theta. That's what given. So how do you calculate? Sine theta by cos theta equal to f by f, which is 1. Agree? So sine theta by cos theta is a tan theta. So tan theta is 1. Do you know like where you will get 1 for tan theta? At tan 45 degrees. So by comparing left side and right side, what you get? Theta? Theta equal to 45 degrees. That is an answer. So theta would be 45 when both components are equal. Sure. So how do you represent in notation? F equal to fxi plus fyj. So fx horizontal component, f cos theta value, f into cos 45, that means like cos 45 1 by root 2, so f by root 2. Similarly, f sin theta is nothing but f sin 45, right, which is also f by root 2. So the answer would be f by root 2 I plus f by root 2 j is your net vector. So that's why I think problem statement also talks about same. At 45 degrees, both components are equal, and hence we get, f by root 2 I plus f by root 2 j. Horizontal component, vertical component, both are same. Good one. Nice. One more simple problem. Right? One more simple problem. A plus ij. What is the angle between the vector and an x-axis? So cute. So when you say a equal to I plus j, the 1i plus 1j, 1i 1j is what is given. 1 unit x direction, 1 unit y direction. That's all I can see now, right? So resultant vector is what we need to know now. Okay, how do you calculate resultant vector? So we have to say magnitude of A is nothing but 1 square plus 1 square. How much? Root 2. So this is a root 2. What is asked is this: the angle between the resultant vector and x-axis. This is what they ask, right? You have a two things, right? So let's look at a cos theta. Cos theta equal to x component 1 by hypotenuse, resultant component root 2. So do you know where you get 1 by 2 for cos theta? It is cos 45 degrees. So this I'm referring from trigonometric ratios. So the theta, both sides, if you can compare cos theta to cos 45 means that theta is 45, is it? So the answer would be 45. See, we can have like the many problems that there is simple way to solve them. So all are like, the magnitude, angle, xyz plane, that short. From the given data, you should be able to figure out what would be the answer. This is simple things. So two more simple concepts we can go through. Okay. So triangle law of vector additions. How many of you remember this concept? Triangle law of vector addition. Law of vector addition. So if you look at this one, right? So we have a vector A and vector B, both are at the starting point, and the resultant also goes to the same point. So the idea is like how you gonna get the resultant vector R. So we know like fundamentally like R equal to A plus B, isn't it, right? But how do you get that? How do you know? So when you look at a vector, what we see is that there is a tail and there is a head. When we add the two vectors, all we have to see, head of the one vector should be connected to the tail of the other vector. That is how you can see adding the vectors, right? But I'm not able to correlate now here, because sounds to me like all the vectors starts at the same point. This is where we have to understand parallel vectors, adding the vectors, subtracting vectors, things like that. So let me move to the next slide so you will be able to understand. You can see now. So we moved like this vector just towards the right to make a triangle. That's why this is called as a triangle vector. So read out this definition. Two vectors of same type are represented in magnitude and direction by two sides of the triangle taken into consideration, clockwise or anti-clockwise. Then the resultant vector is represented in magnitude and direction by the third side of the triangle in the opposite direction. Let's A and B are the same direction. The resultant vector would be the opposite direction. You can see not on the same direction. That's why in the closed loop, if you look at A plus B minus R equal to 0, that is how you represent A plus B minus R equal to 0. This also means A plus B equal to R, right? This is a triangle law. So adding a vectors, right? When you see this is the vector, this is a tail, this is a head. If you add one more here, this is a tail, this is head. That means like you are adding. But this one you see, so you are adding like a two heads. So if you can make it a change, if it is R, right, you reverse this direction and then put a R. Then what happens? You have A, B minus R. So A plus B minus R equal to 0. So A plus B equal to R. So a lot of fun we can get it using vectors. You're clear? So triangle of vector additions. The two vectors of same type are represented in magnitude and direction by the two sides of triangle, clockwise or anti-clockwise. You can take whatever it is. Then the resultant vector representing the magnitude and direction by the third side in opposite direction. Okay, this is what I think your triangle of vector addition. I hope you are clear. The next topic is parallelogram law of vector. So this is a little extension to the triangle vector. Now we are talking about a parallelogram vector, right? What you have to understand is that when P and Q are given, the resultant R is equal to P plus Q. In the parallelogram, how do you get it? The resultant vector R, P square plus Q square plus 2PQ cos theta. This you got to remember for solving the problems. Okay, so theory is so simple. So let's say this is the P, and then for OB you are actually draw another line AC which is a parallel to OB. So since this is Q, I could also say this is Q, isn't it? I extended little, the OP vector to connect to C. This is like a virtual line. A to B and B to C is what I extended. So now since these lines are parallel, the angle making with x should also be same. So I have theta here, and hence I have theta here. So if it is a theta, and then this is a, the resultant vector q for this triangle, then how do you get it? Horizontal component q cos theta, vertical component q sin theta. Right? Now we look at the right angle triangle OBC. Triangle OBC, you can easily figure that out, right? OB means, what is OB? OB is nothing but your P plus Q cos theta. P plus Q cos theta, right? That is what's noted. Whereas BC, BC is a horizontal vertical component, right? That is a Q sin theta is given. Both are there. So now calculating an alpha angle. So resultant making an angle with a horizontal is an alpha. So the alpha would be, tan alpha would be, what is the formula? Tan alpha, opposite by adjacent, right? So I think this is wrong. The q sin theta, q sin theta divided by P plus Q cos theta. This would be your angle. So alpha equal to tan inverse Q sin theta by P plus Q cos theta. Are you clear? So remember, so these both are important for solving the problems. Let's look at this problem. Two forces of magnitude 3 units and 5 units act as 60 degrees with each other. What is the magnitude of their resultant? So what do you think, like, P is given 3 units, Q is 5 units, and 60 degrees is an angle, right? Theta. So what is the resultant? R P square plus Q square plus 2PQ cos theta. Sure, no? So 3 square, 5 square, 2 into 3 into 5 cos 60. Okay. So 9 plus 5 square means like 25 plus 2 into 15 plus cos 60 is 1 by 2. Done. So what would be the value? Root 49 and hence 7. So the resultant is 7 units. Clear? Very good, Ba. Look at next problem. When two right angle vectors magnitude A 7 units and then 24 units combined, what is the magnitude of the resultant? So there is clearly given both are right angle, right? So 7 and 24. So theta is 90 degrees. It's easy, no? When right angle, obviously there's a 2D. If you look at R, P square plus Q square plus 2PQ cos theta. Cos 90 how much? Cos 90 would be 0. So this component is gone. So what we have is that R square equal to P square plus Q square. So 7 square plus 24 square. How much? 49 plus 576. This is 625. So R square is that R equal to 625, square root of 625, which is nothing but 25. Alright, so we have similar kind of problems. We can solve as many as, because the concept is so straight, simple. All you have to do understand is like remember the formulas and application of the formulas. Alright. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. So we reached end of the session today. Thank you all who are made it possible for today. Thanks for your joining. Stay tuned to next session. We'll see you tomorrow. Thank you. Bye bye. Have a good day.